Welcome, this is a Cambridge IGCSE Mathematics Paper 2 Non-Calculator Extended Specimen Paper B. That was a mouthful. Let's get started. Always we have first a list of formula and then we go, remember, no calculators allowed. So write the ratio 12 to 13 in its simplest form. Okay, there are different ways of doing this. Easy way is just to half it. Both is even numbers. We can just half it. That gives us 6 and 15. Can we halve that? No. We can divide both sides by 3. It's like equivalent fractions. So that will give us 2 to 5. Okay, of course, quicker way would be to find the highest common factor, which is 6. So instead of dividing by 2 then dividing by 3, we can just divide both by 6 and it gives you 2 to 5 immediately. Okay, 1 mark for that. There we go. Then a kite. There's the kite. Remember, kite has adjacent pair of equal sides. Okay, you can't do a horizontal line. Line of symmetry means both sides the same but a mirror image, so you can clearly see it's only got one line of symmetry. So again here the answer is just 1 for 1 mark. Then the stem and leaf diagram shows the number of minutes taken by each of 18 students to complete the task. So each one of those numbers on the right represents a person. The first person, the quickest one to finish the task, took 12 minutes. Then the next person took 13 minutes. And that continues all the way to the slowest one, took the longest, which was 39 minutes. It's explained there in the key as well. Okay, so each one of these numbers here represents a person and the time it's taken to complete this mystery task. Okay, now remember, range means you take the biggest or the highest and you subtract the smallest. The distance between the biggest and the smallest. So here the biggest number, the longest time it took somebody to complete the task was 39 minutes, and the quickest, the first one there, 12 minutes, and that will give us 27 minutes. Okay, 27, only correct answer. There we go. Median, of course, means middle. Okay, how do you spell middle? 2 D's. Okay, middle. So we need to line these people up. The guy that was the quickest, 12, is going to stand on one side. And then we go the guy that took 13 minutes, then the person that did it in 16 minutes, and then 19 minutes. And they're going to line up all the way to the slowest, well, 2 people actually, that did it in 39 minutes. This mystery task. Okay. And then we need to say which one of them is in the middle. There are more than one way to do this as well. You can do the crossing off, right? You take the fastest, the slowest, second fastest, second slowest, third fastest, yeah, and you cross them off. And once you get here, this is the next slowest, and this is the next fastest, the next slowest, fastest, slowest, fastest, slowest, fastest, slowest, fastest, slowest. So the middle will be there between the 4 and the 8. Okay, if that confuses you or you think it takes too long, okay, another way of doing it is just to find the middle one. Okay, if you line up 5 people, who's in the middle? The third person. Okay, got 5 people, the middle person will be number 3, right? How you do that with maths? Well, you can't do 5 divided by 2 because that will give you 2.5, which is not the middle, but you need to add 1, which is 6 divided by 2, bam, you got the middle. So we can do the same here. Okay, we can say, hey, there is 18 people. We know that because they told us that. So there's 18 students. We add 1 and then divide it by 2. That would be 19. Half of 19, 9.5. So the middle will be between the 9th and the 10th person. So we just count them. 1, 2, 3, 4, 5, 6, 7, 8. There's the 9th person. There's the 10th person. It's in between them. Okay. Now, those are two numbers. The 9th person took 24 minutes to complete this task, and the 10th person took 28 minutes. Okay, so what's halfway between 24 and 28? You can just think 24, 25, 26, 27, 28. 26, of course. If at any point this is too complicated, I mean, if it's a more difficult numbers, right? There's also, of course, a mathematical way to do this. You just add them together and divide it by 2. What is that? 24 plus 28. 20 plus 40 is 52. 52 divided by 2, 26. Or if you want to double check. Okay. 26, correct answer, only there. 1 mark. Then we get to the pie chart. Okay, remember what is a pie chart? A pie chart is a circle, and a circle is always 360 degrees. So we need to know, yeah, that all these numbers, because it represents all the people, all 18 of them, needs to add up to 360. And each one of these sections need to get their slice of the pie. So let's see. Remember, in total, there were 18 students. And 1, 2, 3, 4 of them did the task between 10 and 20 minutes. That is 4 people out of 18. Okay. But we need to make that an angle out of 360. That's all. We need to change the 4 over 18 to something out of 360. Now you can see that's not difficult to do. What can we do? If we multiply this by 2 equivalent fractions, that will give us 8 out of 36. Nice, because now we can just, of course, multiply it by 10, and that will give us 80 out of 360. But that's not the answer. They want just the angle. Okay, so that will be 80 degrees. That will be the slice of the pie. Okay, so 80 degrees, a little bit less. That would be the people. Alright, that represents 4 people. Okay, so we do the same with the next one. 1, 2, 3, 4, 5, 6, 7, 8. 8 people out of 18. Okay, if you had a calculator, you would just do it times 360. Okay, but we see what we need to do. We need to double the number and times it by 10. So double 8 is 16 times 10, 160 degrees. Okay. Remember, it needs to add up to 360 because we got the whole pie chart. So 160 would be something like this, isn't it? Okay. So what's 160 plus 80? It's 240. So we need another 120 to make it 360. Is that not? Okay. That being a 0. But let's do it like we did the other ones. 1, 2, 3, 4, 5, 6 people between 30 and 40 minutes. They took the task. That means 6 out of 18, which means it's 12 out of 36, which means it's 120 out of 120 degrees. Adds up to 360. Bam, we got our marks. Okay. You get 1 mark if you have 1 correct. So if you got 2 correct, you still just get 1 mark. Okay. If you don't have that right, but they got the calculation, which is this one I told you about, right? then you get a mark for the calculation. So that's why it's good to show the calculation. So if you don't have this correct, you can get a mark here, or else you just get 2 marks for this correct. Okay, maximum of 2 marks, of course, not 3. Okay, on to question 4. We got fractions here. Remember to show all your working out. So we got, no, I don't want to write in red. We got 3 over 7 times 14 over 15. Now, one way of doing this, stick till the end because there's a quicker way. I'm going to show you the long way. Is just remember, fractions, we multiply the top with the top, the bottom with the bottom. So we're going to do 3 times 14. 3 times 14 is 14. 28 and another 32. That will be 42. Is it not? 42. And then we do 7 times 15. What's a quick way to do 7 times 15? Well, you could do 7 times 10 is 70. And then you can do 7 times 5 is 35. Add them together, that gives you 105. See? Easy stuff. That will give you 1 mark because it needs to be in its simplest form, which means we need to simplify it. And we need to find the number that can divide into both. Okay. Now, we can divide both by 3 because if I add the 4 and the 2 together, I get 6. 6 is divisible by 3. So 42 is divisible by 3. 105 is divisible by 3 because 1 plus 5 is 6 again. But I think a better number here to divide them both by is maybe 7. No? Because that will give you 6 out of, what's 105 divided by 7? Isn't that 15? Okay. I know that because 7 times 15 is 105, so 105 divided by 7 is 15. You see, we're starting to go a little bit in circles here. Okay, and then we can divide it by 3. So actually we could have divided by 21, which gives you 2 out of 5. Now, that's the correct answer, but you see, it was a bit lengthy. It's a bit hard. It's a bit, okay? So there's a quicker way. A lot quicker, a lot easier. All right? So, you see that we divided it by 7, divided by 3. We simplified it. If we do that before we multiply, that's a lot easier. Yeah? We can divide this by 3 and that by 3. The top and the bottom. Now, 3 divided by 3 is 1, and 15 divided by 3 is 5. See? And we can divide this one by 7, and we divide that one by 7. We always have to divide the top and the bottom by the same number. So 7 divided by 7 is 1, and 14 divided by 7 is 2. That's easy now. 1 times 2 is 2, and 1 times 5 is 5. A lot quicker, isn't it? Okay, so they reflect that in the mark scheme here. 2 over 5, final answer. So if you got 24 over 105, good. But if you see the cancelling, yeah, which is the other method, which is a lot quicker, that gives you a mark as well. So you either do this and then get the correct answer, or you do this and then get the correct answer. Okay, I think the second method is a bit easier and quicker, but both work. Okay, question 5. A decagon is like a decade, like a decimal. Yeah, that decimal means 10. So it's a 10-sided shape. And they want to know the interior angle. Again, there are 2 ways to do this, so stick till the end, because I'm going to show you the hard one first, and then the easy way, right? We know that the interior angles of any polygon, the formula is the number of sides minus 2 times 180. Okay? That is because if you were to draw a decagon, yeah, 10 sides, I'm not going to draw it, it's going to take forever, right? But there's always 2 less triangles than the number of sides in any polygon. Take a square, for example. It's got 1, 2, 3, 4 sides. Inside fits 2 triangles. Each triangle is 180. That's why 2 times 180 is 360. If you take a pentagon and you draw diagonals without crossing, okay, it's got 5 sides. 5 minus 2 is 1, 2, 3 triangles. So a pentagon is 3 times 180. So for the decagon, it's 10 minus 2 times 180. Now we need to do this without a calculator, which will be 8 times 180. Okay. Let's think, how can we do that? Okay. There's many ways doing this. My favorite, one of my quickest. Okay, whatever works for you. Whichever, find a way that works for you. Again, it's just simply 8 times 100 is 800. And then 8 times 80, well, 8 times 8 is 64. And then we add the 0. And now we add it up. 0, 4, 8 plus 6, 100, 1,440. Okay. That is all the angles in the decagon. Okay, if you add the 10 angles together. Now, important, it's a regular decagon. Regular meaning all the sides are the same. A regular triangle is an equilateral triangle with all the angles 60. A regular rectangle is a square with all the sides 90 degrees. You get the idea. So it means all the angles are the same side. So the next step would be 1040 divided by 10, and we have the right answer, 144. Okay, pretty straightforward, but there is an easier way. Okay, using the exterior angles. Of course, exterior angles always add up to 360. Okay, always. Yeah, look at the equilateral triangle here. Exterior will be 120, 120, 120. 120 times 3, 360. Look at the square. Exterior angle will be 90, 90, 90, 90. 90 times 4, 360. Always. So all we need to do is say, hey, the exterior angles is 360. There are 10 of them because the interior exterior angles are still the same amount. That is 36 degrees. That's the exterior angle. So if they just draw up, I'm just going to draw part of a decagon, okay? The whole thing continues. All right, so now we've worked out, this is the interior, this is the exterior, the inside, the outside. Exterior angle is 360, and the interior exterior angles, they are angles on a straight line. So together they're 180, subtract from 180, 36, bam. Got the right answer again. Okay, the second one again is a bit quicker, isn't it? Okay, so you'll see that reflected in the mark scheme. Answer is 144. There's 180 minus 36. Or you use that whole formula and divide it by 10. That's what it says here. The one or the other. Okay, so as long as you show a method, and you have the answer. Question 6. Liters to centimeters cubed. Okay, just remember this thing, one thing, right? Think about 1 liter. Think about a box of milk you might have in the fridge. If you have boxes of milk where you are, yeah? The long life milk, you know, boxes, right? It's like a box. Imagine that just not being a cuboid, but a cube. Okay, how big would that cube be? Okay, that cube will be, if I draw it like this, 10 by 10 by 10 centimeters. Okay, little cube like this, 10 by 10 by 10. That's exactly what 1 liter is. Okay, now 10 times 10 times 10 is 1,000 centimeters cubed. Okay, this you need to remember. If you're going to visualize it, it will be easier to remember. Okay, so that simply means that 5.7 liters will be 5 point something of those. So you need to multiply that by 1,000. Okay, which of course will give you 5,700 centimeters cubed. Okay, so you need to remember that fact. 1 liter is a cube that is 10 centimeters by 10 centimeters by 10 centimeters. 1000 centimeters cubed. Question 7. For me, the best way is change everything to decimals. They are so much more easily compatible. Okay, so we already have one there. 0.143. Okay, let's do the 3 over 20. How do we change that to decimals? Decimals is tenths, hundredths, thousands. So if we can change this below to 100, 20 times 5 is 100. So we can change to hundredths. Equivalent fractions, we have to do the same for the denominator and the numerator. 3 times 5, 15. Okay, so that means 3/20 is 0.15. Okay, if you want to compare it to the one below, you're allowed to put a little 0 there, because 0 doesn't actually change the number with decimals. With normal numbers it does. If you've got a 5, you put a 0, now you've got 50. But with decimals, it's like putting the 5 in front of the 0. 0, 5 is same as 5. 15, 0.150 is the same as 0.15. Okay. So now we can clearly see the top one is bigger. Let's do the 1 over 6. Alright, so 1 over 6 is none other than 1 divided by 6. Remember the bust-off method for dividing stuff? Okay, so we just say 1 divided by 6. Can't do it. That is 0. Now we need to add a decimal. Okay, see 1.0 is still 1. I haven't changed the number. But I can now say 10 divided by 6 is 1. 6 goes into 10 ones, yes. Imagine there's a 10. So 1 imagine 10. Remainder 4. Put the 4 there. Okay, now I can add another 0 here, because 1.00 is still 0. And I can say 6 goes into 40. 6, 12, 18, 24, 30, 36. 6 times remainder 4. Put another 0. 6 goes into 40. 6 times, because 6 is 36. Remainder 4. Can you see I'm going to be doing this forever? It's never going to stop. Okay. So, what does that mean? The number we're looking at here is 0.166 recurring. So 166 is 0.166 ... because those 6's carries on. Okay. What's left? 16%. That one's easy. Percent means out of 100. So the same. 15 over 100 is 0.15. 16%. That will be 0.16. And again, we can put a 0 there, so we can compare it with the other numbers. Now it's a lot easier. The smallest you can see is going to be 0.143. 143 is the smallest. Second smallest, the first one there, 150, or 3/20. Then 160, or 16%. And the last one, 1/6. Let's look at the mark scheme here. Okay, how did they award marks? That is the question. So when you write the answers and you write the decimals on the line, they accept that. That's what they say here. If you got 3 in the correct order. Okay, so let's say I had the 3/20 in the front, and then then you get 1 mark. Okay, and then if you got this wrong but you've converted them all correct, you can get a mark for that. Okay, so show as much as you can. Show you're working out, and then you get your marks. Always smart to show everything you do. Question 8. Right, there's the spinner. Goes around. Got the numbers 1 to 8. Pretty straightforward. Okay. Then it says, find the probability the spindle lands on a number greater than 6. Not 6, greater. This means only 7 and 8, which is 2 numbers. 2 numbers out of how many? 8. That's all. Okay. Did they say you have to simplify? No. Okay. So that's why it's 2/8. Or equivalent OE. So if you did write 1/4, it's correct. If you did write, let's write those things down. You can write 1/4. You can write 4/16. Yeah. You can write 25% or 0.25. I mean, that's all correct. Okay. An even number and a multiple of 7 is the next one. Okay, what are the even numbers? It's a 2, a 4, a 6, and an 8. And multiples of 7, the multiples, multiplication tables. Which of these numbers is the multiplication number of 7? 1 times 7 is 7. 2 times 7 is 40. Only this one, right? It's a silly way of to say all the even numbers and 7, really. Okay, how many is that anyway? That's 5 out of 8. Okay. And that's correct. Okay, then Jude spins the spinner 240 times. Work out the number of times to spin the lamp to a number greater than 6. Remember, the probability for that was 2/8. 2 out of 8. That means if we spin it 8 times, we're expected that it would land twice on 7. And that makes a lot of sense, right? Okay. That also means if we spin it 16 times, we expect it for it to land 4 times. Okay. So, what about if we spin it 240 times? Okay, how do we change 2/8 to 240? Well, let's do it in stages. Okay. First we can multiply it by 3. 8 times 3 is 24, so 2 times 3 is 6. So if we spin it 24 times, we expect it to land 6 times on a 7 or 8. And then we can times it by 10. So that is 60 out of 2. So we expect it to land on a 7 or 8 greater than 6, 60 times. Of course, another way, the calculation is you just always multiply the probability with the number. So it's 2/8 times 240. Okay, how do we do 2/8 times 240? There's different ways. I think if we simplify this one first, it will make it easier. You can put that one on 1, and then we can simplify the top and the bottom. We divide this by 4, that is 1. Divide this by 4, 240 divided by 4 is 60. 1 times 60 is 60. 1 times 1 is 1. Bam. See, same answer. Different way. Okay. Just one mark here to be given away. So whichever way you want to get it. Okay. There is a follow through mark though. So if you got the previous one wrong, but you multiply that by 240, get the right answer there. Bam. You get your mark. Okay. On to question 9. And remember, what is a rhombus? A rhombus is like a square that has gone wonky. So it's a parallelogram with all the sides the same length, like a square, but the angles is not 90 degrees. Okay, so the side length is 6 centimeters. If you've photocopied or printed your paper like I have, that line might not be exactly 6. So just make sure it's exactly 6 centimeters. An exam it will be. Okay, so the first thing we need to do is we need to make side lengths of 6 centimeters. So it means from this point there needs to be a line going somewhere that's exactly 6 centimeters. And the same here. So I'm going to do that. I'm going to open my compass exactly 6 centimeters. Somewhere here from this point a line is going to extend and be exactly 6 centimeters. I don't know where, so I'm going to make a nice big arc to show that. Okay. From here to there's going to be a line that's exactly 6 centimeters. Now if we want to draw an equilateral triangle, of course we'll just draw the lines there, but we don't. Okay. We want to draw a line here that goes 6 centimeters, but we don't know where. But what we do know is the diagonal is 9.5. So if you think about the rhombus there, or rather, if we want to make the rhombus go the other way, this is 6, that is 6, and this diagonal will be 9.5. So meaning from this corner to somewhere over there, there needs to be a line that's exactly 9.5 centimeters. So we do the same now. We open our compass, 9.5 centimeters. We put it here, we make an arc. And now we know that this line from here to there, this will be 6. Look at it. I went a bit too far. That will be 6. The diagonal from here to there, gonna do it lightly. That's 9.5. So this is 6, 6, 9.5. We now need another line that's parallel to this one, right about there, but we want to be very accurate, so we need to think that from this point here there's going to be another line that needs to go 6 centimeters, right about there, but we want to be exact, so we're going to use our compass for that one as well. We're going to open it up 6 centimeters. And we're going to make an arc from this point there. So where those two arcs cross, yeah, this is exactly 6 centimeters from there, and this is exactly 6 centimeters from there. Look at that. Seems like I'm 1 millimeter out. And there we go. A rhombus where all the sides are 6 centimeters, opposite sides are parallel, and we have a diagonal that's 9.5. You get marks here for drawing an accurate rhombus. Okay, but to get full marks, you need to have these construction lines. Okay, if you don't have the exact construction lines, maximum mark you can get here is 1. Never rub out your construction lines. That's how you want to leave it. Right, back here to question 10, and this time Rafik is a busy person. He's doing meetings, planning, he's working on the computer. Okay, how many hours a month does he work? Hopefully not too much. So let's have a look. Meetings is 3/4 of the time and planning is 1/5 of the time. If we add those two together, okay, we will know how much time has gone meetings and planning. So let's do that. So if he works for 3/4 of the time is in meetings, boring. Planning for 1/5, that's important. We need to add it together, these two fractions. Now remember, if we want to add fractions together, we need to get the denominators the same. The lowest common multiple of 4 and 5, of course, is 4, 8, 12, 16, 20, 5, 10, 15, 20. It's 20, right? Okay, so it means we multiply this by 5. 4 times 5 is 20. So it means 3 times 5, 15. And we multiply this one by 4. 5 times 4 is 20. 1 times 4 is 4. So 15 plus 4, 19/20 of the time that he works is meetings and planning. So how much time does he spend on the computer? Well, that would be, of course, 1/20 of the time. So the computer time is 1/20. So 1/20 is equivalent to 25 minutes. So 2/20 will be 50 minutes. 3/20 will be 75 minutes. Okay. So what do we need to do, right? We need 20th. That is all the time. Okay, and how do we get from 1/20 to 20? We're trying to multiply with 20. Yeah, 1/20, which is the time he spends on the computer. We multiply it by 20 and we get the whole time, the whole 20, the whole 100% of the time. So we need to do the same. We need to do 20 times 25. So 2 times 25 is 50, and then we just add this 1 0, and that will give you 500 minutes. That is how much time he works a day. That seems a lot, 500 minutes. Now we change it to hours and minutes. Yeah, time is that horrible thing where we don't count like normally. We count up to 60 and then we start over counting again, not like up to 100. You go 100, you go 101. But time, you go 60 and you switch. Yeah. So we need to do 500 divided by 60. How are we going to do that? Well, that will give it be the same as doing 50 divided by 6. That is the same answer. We can just cancel the zeros. So what's 50 divided by 6? 6, 12, 18, 24, 30, 36, 42, 48. 8 hours. 8 hours is what he spends. So we got up to 48, or rather 8 times 60 is 480 minutes, but we need 500, so that is 20 minutes more we need. Does that make sense? 8 times 60 is 480, but 500 is 20 minutes. Yes. 8 hours, 20 minutes. You get 4 marks immediately if you write down 500 minutes. Okay, so this is how it goes. Let me show you. Okay. Alright. If you show that you're going to add the two fractions together, you get a mark. Get a mark for this. If you then subtract it, so you get 1/20, yeah, 1/20, or something similar, and 500, then you get a mark, and then a mark for the final correct answer. That's straightforward. Okay, remember, time is weird. We don't count it like we count normally. Good old algebra next. Let's see. 2 times 3 is 6. Expanding the brackets. X times x squared is x cubed. Then we do 2 times minus 8 minus 16. X times x, x squared. Straightforward. There we go. Final answer. Okay. Basically get 1 mark for this, 1 mark for that. Factorising. Remember, if this is a square number or something squared, and this is a square number or something squared, and there's a minus in the middle, that is the easy thing. You just square root the x squared, which is x, square root the 19, which will be 19, 19 squared will be 19, okay, and you put a minus, and you put a plus. It only works if the both numbers there is something squared, okay, square number, and there's a minus in the middle, okay, because look what happens. Okay, let me do this a different color. Okay, remember this. Okay, if I were to expand these brackets, okay, we'll do x times x is x squared. So you could, we got that. Then x times 19 is 19x. Minus 19 times x is minus 19x. And 19x minus 19x is 0. That's why there's no middle term. And then minus 19 times 19, a minus and a plus is a minus. And 19 times 19, I'm not going to work it out, but it will be 19 squared. Okay, so these two middle ones will cancel, and you'll have that. That's why this works, okay? That's why with the next one, let me just show you the answer, the mark scheme, okay? The plus and the minus could, of course, be in any order. Plus, minus, minus, plus, that doesn't matter. It's only one mark there. That's why for the next question, we can do the same. Okay, we now know, look, that is something squared, so this will be 81 minus 19 and 81 plus 19. Don't go and try work out 81 times 81 and 19 times 19. There is people that do it, they get the right answer, but it takes a long time, more than 2 minutes. And this is how long it should take you to do this question, 2 minutes. Okay, now 81 minus 19, 81 minus 9 is 72, 62, right? 62. And 81 plus 19, 81 plus 9 is 90, 90 plus 10, 100. 62 times 100, 6,200. Shouldn't take you any longer to do that question. Okay? See, 1 mark for this part. And then if you don't get any of that correct, they give you marks for these digits. I guess that is when you do 19 squared or 81 squared. This is a special case. Only if you did not get the other marks. Okay. But you can get a mark for this and a mark for the answer. Nice. Next question. 12. They're bringing a little bit of physics. How exciting. Okay, remember there is a square surface. Pay attention to the details. Every detail is important. Get your highlighter out. Highlight it. This is square surface. You think, okay, square surface. That's the square surface, which is 4.9 and 4.9. Good, okay. By writing each number correct to one significant figure. Read your questions carefully. They tell us we need to write each number to one significant figure. That means 196. If we round it to the first figure, we need to cut it off there. Next to the 1 is a 9. We need to round it up to a 2 and put 2 zeros because it's a 200, not 2. You don't write 196 to 2. 4.9. First figure there is the 4. Next to it's a 9. 4.9 is 5. Okay. The force, that's the force. Force is 196. We rounded it to 200. Divided by the area. Okay, remember now, we've rounded this square to a square that is 5 plus 5. So we need to divide it by 5 squares. So the calculation here for the pressure. See, there's another clue there. If there's anything maths teachers should just pay attention to the little details, yeah? That also tells you the newtons divided by the centimeters squared. The newtons divided by the centimeter squared. It's all in the units. Units is important. Okay, so that means you need to do 200 divided by 5 squared, which is 200 divided by 25. 25, 50, 75, 100. 125, 150, 175. 8 newtons per centimeter square. Okay. Can a physicist please tell me if that's a lot or not? Okay, so there you go. 1 mark for the 200 or the 5. So for one of these, a mark. Then for the calculation, of course you can write 200 divided by 5 squared and then a mark for the answer. This is a question, if you just pay attention to the detail, read carefully, it should not be too difficult. Moving on to question 13. we got transformations. Remember, there's 4 transformations. Okay. There's translations. See, I'm immediately in pencil. Translation, of course, if we were to trace this shape, is where the shape moves across the page. That's clearly not a translation from A to B. Okay. Then we got reflections. That's when we form a mirror image. We kind of say the image flips over in an axis. That will be a reflection in the y-axis for it. Of course, a symmetrical mirror image. Then we got rotations. That is when a shape rotates around the point, which looks like that might have happened there. We'll do more on that later. And the last one, enlargements, and that's the only one where it changes size, bigger or smaller, even though it's called an enlargement. So first question here, draw the image of triangle A after reflection in the line y equals x plus 2. Okay. As all the neighborhood dogs are barking, let's do this one. So we need to draw this line first. Not difficult to draw. If we make x 0, we'll get y equals 0 plus 2, so it means y equals 2. So that line will go through y, through 2 on the y-axis. If we make the y 0, we get 0 equals x plus 2. Move the 2 to the other side. So minus 2. That means it will go through minus 2 on the x-axis. Or we can put any other point in there. If we put 1 there, if we make y 1, and 1 plus 2, of course, x is 3. There's another point. See, I've got now 3 points. Straight line. So that will be the line that this shape needs to be reflected in. So draw that clearly on your grid. Okay. Now, there's different ways of doing this. We can flip it over in that line, get a good idea what the position would be like. Something like that. Okay. Another thing to remember is the distances are exact. From this point here, so diagonally half a square, perpendicular to the middle line. From the line is this point, so we do the same on the other side. Half a square, diagonally perpendicular. So that point will reflect there. This point here, we go diagonally 1.5 square, forming a perpendicular angle. Do the same on the other side. We go half a square and then 1 diagonally. That point will reflect over there. The last one, be careful, don't let this line confuse you. We have to go diagonally 1, 2, 3 squares, forming a perpendicular line. Do the same on the other side. 1, 2, 3 squares, and that point will reflect over there. Okay, so it will be right over here. See that? I shade it a little bit so we can see it better. And you'll know when it's right. It will just look right. It's symmetrical. It's the same distance. It's a mirror image. Okay. Get 1 mark for drawing the correct mirror line. And then 1 mark for the shape in the correct orientation. and 1 mark for being in the right position. Next one, the enlargement, center 1, 0. So remember, go along the corridor first and then up and down the stairs, which means the point 1, 0 is right there. Okay. Now, this is a fractional enlargement, yeah? Means the shape needs to get 1.5 times bigger from this point. We are right on top of the shape. So this bottom, this right hand corner, right angle here, would stay right where it is. This point here is 3 squares away from the center of the enlargement. We need to now make that 1.5 times bigger. It's like saying, what is 3 times 1.5? Enlarging something by 1.5 means you take the size and then you enlarge it by another half, which is weirdly 1.5. That might not make a lot of sense, which will make means the new shape is 4.5 squares away. No, yes. Yes. So from here, not at 4.5, the point there, 4.5 squares away from the center. So 1, 2, 3, 4.5. Okay. The other side here, we need to take side 2 and increase it by 1.5. Now this one will make more sense. So we take the size 1 and we increase it by 1/2 of 2. That's 1. That will give us 3. So 2 becomes 3. 2 squares away becomes 3 squares. The new point will be there on that middle line. So the new triangle is right on top of the other one. So it's 1.5 times bigger. Right on top. This is a strange question, I have to say. Okay, so 1 mark for a triangle that is 3 by 4.5, base of 4.5, height of 3, right angle triangle. 1 mark, and another mark for being in the right position, right on top of that one with the corner lying on 1, 0. Last question here, describe the single transformation that makes triangle A onto B, right? 3 marks, make sure you write 3 things down. The first thing we want to write is which one of these transformations it is. And as we showed before, okay, if I put my pencil here, okay, it's not a translation, it's not an enlargement, I think, but if we put my pencil here or there or anywhere, really, and we rotate it, we can see it goes in that. So it's definitely a rotation. So we write down rotation, that would be the first mark. Next thing about a rotation, it's got a center of rotation. Okay, there is a way to do this, find this with a compass. Okay, but I think it's quicker doing trial and error. Okay, so if we put it at the point 0, 0, we can see we're about 3 squares to the side. So let's move our center, put it back there. Okay, let's move it 1 square to the left. See, we're getting closer. Okay, let's move it another square to the left. Now we're too low, so let's go up 1. Bam, got it on my 3rd try. Right when my dog starts barking. So you see where that center is? Right there. Along the corridor to -2. Up the stairs to 1. That's the center of large. That's our second mark. And the last one is describing the direction. Okay. So look at your wall clock. Yeah, we're going in the direction that the arms on a clock is going. So that will be clockwise. And then we need to explain the angle. That's how we go straight from our center to the shape there. And we go to there to the same point. You can see, what is that? That's a 90-degree angle. We've rotated 90 degrees. Okay. So we show it any other way. 90. 180 would have been over there. 270 over there. Of course, you can go anti-clockwise all the way around 270 if you want. Keep it simple. It's 90 degrees clockwise. Okay. 1 mark for rotation. Not rotations, rotation. Center -2, clockwise 90 degree. And you got it. Back to question 14. Write 0.38 recurring as a fraction. Okay, there's only one correct method to do this. That is when you make the decimal equal to x. Okay. Now my favorite way is simply to do this. There's one number that's recurring, so we're going to multiply it by 10. Another way is to say there are two decimal numbers, so you multiply it by 100. Okay. So now it gives me 10x. And we just move the decimal point one space. That will give us a 3.8. Remember now, these 8s, they go on into infinity, which makes it difficult to write something as a fraction. We've got something that goes on forever. Right. Now we're just going to, again, take the first equation there and just pop it underneath. X equals 0.3888 going on for into infinity. Okay. It's very important that you line up the decimals. Okay. They need to be lined up, the decimals. Okay. Because now you can see I've got the 8s also lined up. So now if we subtract these two equations from each other, the infinite 8 minus the infinite 8 will be 0. And the one on there, all the 8s will cancel each other out. Because 8 minus 0. Till we get here to the first decimal place, then we got 8 minus 3, which will give us 5. And then 3 minus 0 is 3.5. And the rest of the 8s are gone, which is a big relief because infinity really scares me. 10x minus 1x, of course, is 9x. So if we want to know what is x, it will be 3.5 divided by 9. Bam, we got the fraction. But the problem is we don't mix decimals and fractions because there's also infinite ways then to write it. So we need to get rid of that decimal above the line. That's easy. We do equivalent fractions. We just multiply this by 10, which means we need to multiply the bottom by 10, of course, because we want the fraction to stay the same. That will give us 35 over 90. Sweet. Okay. There is the answer. Is it in its simplest form? I doubt it, because you can clearly divide both by 5. Okay. 35 divided by 5 is 7. And 90 divided by 5, what is that? 20 divided by 20. So that would be 18, isn't it? 7 over 18, I believe, is the answer. Okay, you're not sure how to do 90 divided by 5? Do the little bus stop. 5 goes into 91s. Remainder 4. 5 goes into 48. 18 it is. Yes. Okay. 7 over 18. Correct answer, only for full marks. Okay. Alright. You see here they said you should have done 100. Okay. This is the same thing as me. Okay. So, and they use a K instead of an X. I don't know, they're a bit weird there. Okay, basically, you get 1 mark for doing this, multiplying by 10 or 100. 1 mark for getting the unsimplified fraction, and 1 mark for the simplified fraction. Right, Freya likes to do crosswords and she likes to write difficult puzzles of how long it takes her to complete them. And now we need to figure it out. Let's see. First is Monday. Monday she takes 10% less time than Tuesday. Okay, we don't know how long it took on Tuesday, so let's look at Tuesday. No, Tuesday it took her 10% less time than on Monday. And then on Wednesday, she takes 50% less than on Tuesday. On Wednesday, she took 9 minutes. Oh, thank goodness, finally there's her time. So it's 9 minutes on Wednesday. And on Tuesday, so 9 minutes is 50% less than on Tuesday. So if we say Tuesday is X, we need to multiply X by 0.5 because it's 50% less. Remember, 50% is 0.5. Then we get Wednesday. So Tuesday is 0.5 X. Or rather 9 minutes. So we want to know the time it takes on Tuesday. We need to do 9 divided by a half. Now how do you do 9? You can do 90 divided by 5. Hey, we just done that. Okay, but easier. If you got 9 pizzas and you chop them each 1.5, how many halves do you have? 18. Yeah, okay. There are 2 halves in 1. There's 4 halves in 2. You know, this kind of just doubles it. Bam. Or you just think, you're going backwards, right? So it's 18 minutes on Tuesday. Alright. Now let's make Y Monday. So if Y is 10% less on Monday, how do you do 10% less? You take 100%, that is all the time it took you on Monday. You subtract 10%, you're left with, subtract. So 2 days is 90% of Monday, or you multiply it by 0.9 and then you would get 18. So what do we need to do? We do 18 divided by 0.9. How do you do 18 divided by 0? It can't be this hard. Look. It's the same as doing 180 divided by 10. No. By 9. You understand that? 18 divided by 0.9. If we times this by 10, times that by 10, it's the same calculation in the end. Both answers would be 20. 20 minutes. What is 10% of 20? 20 over 10 is 2 minutes. So you reduce from Monday to Tuesday by 10%. By 2 minutes you get 18. That means Monday it was 20 minutes. This is my best attempt at explaining this question. It might not be the best way to explain this, but it's my best attempt. I hope it made some kind of sense, because you're looking at the mark scheme. Yeah, I'm not even going to try to explain that. Okay, out of the way. The answer is 20. This whole thing is about thinking backwards. That's what they do. They make your brain into a knot. That's what these people from Cambridge do. They knot your brain. Think backwards. I hope you get that. Question 16. Column vectors. Okay. You always give these questions without any pictures. You need to imagine your own picture. Okay, we got PQ is 3 minus 1. PQ, you see got a little arrow. 3 minus 1. And then we got QR, which is 1, 9, right? Yes. So what does that mean? Okay, remember with column vectors, let's put this in red. You have a number at the top and a number at the bottom. The number at the top tells you how many squares to go left or right. If it's positive, you go right, of course. Negative, you go left. The number at the bottom tells you how many squares to go up or down. If it's positive, you go up, of course. Negative, you go down. So, let's first do PQ. PQ, let's pick a point here. Let's say that. This is the point P. We need to go 3 squares to the right. 1, 2, 3. Minus 1 means we need to go 1 square down. Now this will be the vector. Vector's got direction and strength to the point Q. That's the vector PQ. Right, let's do the next one in orange. Now we're at Q. You see? Q, Q. That just got meaning. So we're going from Q to R. It says we need to go 1 square to the right, because we got a 1 here. So we go 1 square to the right, and then 9 squares up. 1, 2, 3, 4, 5, 6, 7, 8, 9. That will be the point R. So QR. Now that, ladies and gentlemen, is ugly. Let's try with the ruler. That's not bad. That is the vector QR. Okay. So, what do they want to know? They want to know the length of PR. PR. That forms a new vector. This one. Okay. Which we call vector PR. How do we get vector PR? Well, we've just added the 2 vectors together. It was PQ, then QR. If we just add them together, which means we do 3 minus 1 plus 1, 9, we'll get that line. See, 3 plus 1 is 4. Look at this. 1, 2, 3, 4. Minus 1 plus 9 is 8. 1, 2, 3, 4, 5, 6, 7, 8. The 2 vectors, you add them together, you get the new vector. Okay, what does that also form? It forms a nice right angle triangle. Now we know the bloke that works with right angle triangles. His name is Pythagoras. Okay. A right angle triangle with a base of 4 and a height of 8. So we just need to work out the hypotenuse here. So how is that going to look in your paper? Right, first you need to say, I've got 2 vectors, the one on the back of the other, so I need to add them together. Okay, so PR equals 3 minus 1 plus 1 over 9. Oh, do not put a little line there because it's not a fraction. 3 plus 1 is 4. 9 minus 1 is 8. That's the new vector, 4, 8. It's simply a vector that goes 4 to the right, 8 up. So if you want to write the length is indicated by these 2 lines. Absolute value, which is positive. Okay, we need to do Pythagoras. Remember Pythagoras, okay, will be the hypotenuse squared. Remember this is 4 and 8, so it's hypotenuse squared, or in this case it's PR squared. Yeah, PR squared equals 4 squared plus 8 squared, or if you move the square to the other side, is the square root of that. So it is simply the square root of 4 squared plus 8 squared. 4 squared, of course, 16. 4 times 4 is 16. 8 times 8 is 64, which will give us 80. Which will give us 80, root 80, that is the answer. Okay. What bothers me, they didn't say anything of how to write the answer. But that is what they said. Square root 80 or equivalent. What could be equivalent to square root 18? It's top of my head. If you did some Surds here and you did 4 times 20, square root of 4, so 2 square root 20. Or even 4 times 5, so it will be 4 square root 5. But you don't need to do that because they didn't say anything about Surds. Marks is awarded here for adding the two vectors together. Okay. And then there's the square and square. So whatever you got the answers after you add it together, if you're squaring the two numbers, those two numbers, if you square them, you get another mark. Nothing, there isn't anything about the root. And then for the final answer. You genius. On to question 17. Which looks like it could be hard, but just think pizza. You see a sector? Think pizza. Okay. So they give us this pretty weird shaped pizza slice. And they tell us the area of the sector, which is this thing, the pizza slice, is 15 by centimeter square. Okay, so to think about what's going on here, we just need to think about the area of a circle. Area of a circle, of course, is pi radius square. And this is what it is. This is just a part of a circle. You know, like a pizza. If you got a pizza and you cut it into sectors, yeah, then for example, this sector will be 1/4 of the whole pizza. And that, of course, is the formula for the area of a sector. Is the fraction of the thing. Is how do we know what fraction this is? Well, this is all about the angle here, which they like to call theta. The Greek theta. Right. That angle, that's the fraction of the whole pizza you have, times pi r squared. Okay, now what we do have information in that formula. We've got the actual area, which is 15 pi. We don't have the angle. We know about pi, and we do have the radius. There it is, 6 squared. Okay, so what is that? What can we do? What can we do here? What can we do? Well, immediately I can see if I divide the pi over there, the pi's will cancel out. And we'll be left with 15 pi 360 times 6 squared, 36. Now before I go crazy and go divide 36 on the other side, is just we put this over 1, and again, cancel the fractions. Divide this by 36, will make it 1. Divide this by 36, that will make it 10. So that gives us 15 equals pi over 10. Multiply the 10. That's not 10, that's 0. Where's the 1? Okay, and we have that angle in the middle as 150 degrees. That's one way of doing it. I mean, you can, yeah, doesn't matter. Okay, that means this angle here is 150 degrees. I work out the angle because there's nothing else I could do, is there? But it is very helpful to work out the angle, because then we move on to the next part. Work out the perimeter of the sector. Whenever they mention perimeter, imagine you're a little ant. You stand in this corner and you walk on this line. And you need to keep walking on this line until you get back to where you started. But first, what have we walked here? We've walked something called an arc, which is a part of the circumference of the circle, which is the next formula. The circumference of a circle, of course, is pi times diameter, or rather, if they've given you the radius, 2 pi r. Okay, that will give us the circumference of a whole circle. But then an arc, again, is just a fraction of that, just like the sector. Okay, arc length is the angle in the middle over 360 times the circumference. Now we got the angle in the middle, that's 150. Okay, and we got the radius, which is 6. Now we can simplify that. 150 over 36, of course, is 15 over 36. 2 times 6 is 12. That gives us 12 pi. You can put it over 1. Again, we can simplify this. 36 divided by 12 is 3. And 12 divided is 1. Okay. And then 15 divided by 3 is 5. And that's it. Then there's a pi. And that's so nice, because that means the arc is 5 pi. But remember, we've only walked up to this corner here. The ant needs to get back to where he started, which is over there. So he needs to walk on a straight line another 6 centimeters. And then down this line, which is just another radius, which will also be 6. So that means to that 5 pi, we need to add 6 twice, which is 12. And that is the perimeter of the shape. Oh, be careful, they want it in that form, so I guess we're gonna have to put the 12 first and then the 5 pi. Okay, 12 plus 5 pi. Correct, final answer, yeah? Let's look at the marks. Alright, looks for me like I give you a mark over here, give you a mark over here, give you a mark for adding 12, and then for the final answer. Nice. Right. Then the next part of the question. They say this sector, just draw it. Okay, this is the sector. We know this is 6. We know that the area is 15 pi centimeters square, and this is centimeters. It's part of a prism, so they made it down to a 3D shape. You know, can you see that in? It's now like a elongate prism with a length of 10 centimeters. Okay, now remember, volume is measured in centimeters cubed, like they tell us there. Okay, so the area of any prism is the area of the front face, which is this, times the length. Centimeters times centimeter square, centimeters cubed. 15 pi centimeter square times 10 centimeters is 150 pi centimeters cubed. Okay, it's only one mark, so you multiply two numbers together and you get the answer. There's nothing more to it. Okay, and then they ask for the total surface area. Let's think of what the surface area would look like, okay? If I use this sketch, right? Of course, there is a... There. It's like this. 3D. There's going to be the front face and the back face. Okay. the front face, which is a sector, and the 2, so it's times 2. So that will be 15 pi for the front face and the back face. So times 2, that is 30 pi. Okay. Then there are a few rectangles. Okay, there's the bottom rectangle here. Can you see that? Which is a rectangle which is 6 by 10. Okay, so that will be 6 times 10, which is just 60. Then there's the side rectangle here. See, on that side there. Which again, the radius there is 6. So again, it's 6 times 10, which is 60. Okay, so those are the two rectangles. And they're both 6 by 10. And then there's the curved face. Okay, curved face is this one. No, this is not working. This one here. Okay, it's getting a bit messy. Okay, sorry about that. Alright, so the curved face, let's do this in green again, is this length here and that length there. So it's like a big rectangle, but it's curved. And that curve here is this curve here, which is this curve here, yeah? It's a rectangle attached to that. So that length is 5 pi. And the length again is 10. So for that one, we're going to do 5 pi times 10, which is 50 pi. So adding that together, we can add the two 60s together, which is 120. And we can add the 30 and the 50, which gives us 80 pi. 120 plus 80 pi. Let's look at the marks here. So multiplying things by times 10, 1 mark, multiply that by 10, and then the final marks there. In question 18, we are completing the square. Remember how to complete the square. You make a bracket. You take that x, you write it over there. You take this number and you divide it by 2. So half of minus 8 is 4. Then you square it. So we got x minus 4. Why do we do that? Well, let's show you. If I've got x minus 4 squared, which means x minus 4 times x minus 4. X times x is x squared. Bam, we got that x squared. Nice. Okay. X times minus 4 is minus 4x. Minus 4 times x is minus 4x. Together, this will make minus 8x. Bam. Nice. We got that. And then minus 4 times minus 4. Two negatives makes a plus. 4 and 16. We don't have that. That's why when you always complete the square, you need to take this minus 4. You need to square it and subtract it. So there's the plus 16 there, which is not in our equation. But if we just subtract the 16 there at the end, it's not a problem. We have the same thing. But there is this 10. Don't lose it. It's hanging around. Okay. So we got the x minus 4 squared. Minus 16 plus 10 is minus 6. Now if we expand the brackets, okay, we'll get the two middle terms. The 2 minus 16s will cancel out. And then we'll have the 10 there. Because minus 6 plus 16 gives us the 10. We're sorted. And that's the answer. X minus 4 squared minus 6. There it is. Look at the mark scheme. Basically, you could say you get 1 mark for minus 4, 1 mark for minus 6. Okay. Now they say sketch the graph. You don't need to show everything, okay? Take a pencil and look carefully. the turning point. Okay. Now this you just remember. The turning point is given for us in that answer. Okay. All you need to do is you take what's inside the bracket. That will give you the x-intercept, but you have to change the sign. But this one over here, you take it just as it is. So a negative becomes a positive, positive becomes a negative. Only for the x value, the y value is the one at the back. That is the turning point. So the point 4 minus 6 will be roughly over here. Okay. Turning point, of course, because this is a parabola. Smiley face. Yes. And it's not upside down. If there was a minus in front of the x squared, it will be upside down. This one is not because it's a positive quadratic graph. Okay, and we know it will be turning down here. But what we need though is the y-intercept. Where do we find the y-intercept? Well, there's a y. But the other thing, on the y-axis, the x is always 0. Okay, so this whole line, the x is 0. Because remember, x here is 0. X here is 1, 2, 3, 4. Minus 1. X changes as you go left and right. But it stays the same as you go up and down. X is 0. So if we want the y-intercept, we just make x 0. Which will give us 0 squared minus 8 times 0 plus 10. That would eliminate the x squared. That's 0 minus 0. So what are we left with? 10. So it's a line that will go through 10 on the y-axis. So you need to draw a parabola. Smiley face. That goes through 10. Okay, make sure you show it 10. I'll make it 10 and then go through here, yeah? If you put a 10 there, it needs to go through that 10. Okay, and that's it. I'll make sure the turning point, yeah, let's make it, that's it. Shows us the turning point. Alright, so look at the mark scheme here. You get 1 mark for just the general correct shape. 1 mark. Parabola, the right way around. 1 mark for going through 10 there. Okay, and then 1 mark for the turning point 4 minus 6. If you had this wrong, but then you could conducted this correctly, right? Then you can get a follow-through mark. If you've used your wrong answer here to get a turning point, which is different. Okay, use a pencil. If you make mistakes, you can rub it out. Question B. The moment we get to graphs and gradients of curves, not talking of straight lines, of curves, then differentiation. Okay, let's see. On the graph at P is 6. So there's a line. Okay, somewhere there's a line where the gradient is 6. Okay, you can imagine maybe it's a line. It won't be here on the left because it will be a negative gradient, so it's a positive gradient. Okay, it's like there's a line and the gradient is 6. It's quite steep. For every 1 square we go to the side, you go 6 squares up, and it touches the ground. It's a tangent of the gradient of 6. Oh, well, the gradient at that point is 6, so if we draw a tangent at that point, it will be a line. Okay, how do we find the gradient at the point? By differentiating, right? So it will be dy over dx. Differentiation. You need to multiply the index with the coefficient in front. There's nothing there, so we say there's a amount. 2 times 1 is 2. X, and then subtract 1 from the index. 2 minus 1 is 1. You don't have to put the 1 because it just stays the same. Okay, imagine here's the 1 here. 1 times minus 8 is minus 8. Subtract 1 from 1 and you get x to the power of 0, which of course is 1, so the x falls away. And you could say there's an x to the power of 0 here, which is just 1, and 0 times 10 is 0. So any numbers just falls away when you differentiate. So that is the differentiated equation of that curve. Okay, and then if you put an x value in there, you can get the gradient at that point. But they give us the gradient, which means this is equal to 6. Okay. So we just need to solve x here. So we do 2x, add 8 on both sides, which gives us 2x equals 14. Of course, then we divide the 2. So x is 7. So that line is not in the right place. Okay. It will be a line way up here where y is equal to 7. X is equal to 7. What am I saying? Okay, so we got the x is 7. We just need the y now. Where is the y? Right over there, there's a y. How do we get it? By putting the x there. So we get y. We know x is 7 now, right? So that will be 7 squared minus 8 times 7 plus 10. Which will give us 49. 8 times 7, of course, is what's that? That's 56 plus 10. I don't like negatives. I'm going to add the 10 to the 49, which gives us 59. So y equals 3. That's the point on the curve where the gradient is 6. 7, 3. There we go. Okay. So, you get 1 mark for differentiating. And even if you make a mistake on one of these terms, you get this mark. If you set it equal to 6, you get another mark. And then if you get 7, get another mark. And then 3, the other mark. 4 marks. You can do this. On to question 19, and we arrived at the surds. Alright, first we need to change this surd to something else. We can think, what square number is there that goes into 25? Goes into 75. The answer is 25. Yeah, because we can do 25 times 3 is 75. So we can write it like that. Okay. 25 times 3. Just think of the square numbers, right? Can 1 go into 75? Yeah, of course, but it's not going to help. Can 4? No. Can 9? No. 9, 75 is not the 9 times table. 16? No. 25, yes. Okay. Now the square root of 25, of course, is 5. Next step, imagine if we had 5x and we take away 1x, we'll be left with 4x. Same here, we got 5 root 3's, take away one of those root 3's, we're left with 4 root 3. And that is the final answer. 4 root 3. Okay, correct answer only, which means nothing else. Okay, you get 1 mark. 1 mark for this 5 root 3 and then 1 mark for the final correct answer. In B, we need to rationalize the denominator. Okay, which means we need to get rid of that root 5 at the bottom. Now remember, root 5 times root 5, which is the same as root 5 squared, what would that be? Okay, so 5 squared is 25, the root of 25 is 5. Okay, it's just 5. So if we multiply this with root 5 over root 5, because that is 1, and we can multiply anything by 1, it stays the same. We can get rid of that root 5, but then we have to multiply the 1 as well, which would just end up with another root 5. And the way to get rid of this is to multiply it by 1 plus root 5. Why? Well, look at this. If we got 1 minus root 5 times 1 plus root 5. We expand the bracket. 1 times 1 is 1. 1 times root 5 is positive root 5. Minus root 5 times 1 is negative root 5. So root 5 minus root 5 is nothing. And then root 5 times root 5, which we determined above, that will be 5. Which in the end those two middle terms will cancel. We'll be left with 1 plus. No, that's wrong. Because a plus and a minus, of course, is a minus. There will be a minus 5. Yeah, because we got minus root 5 times root 5 will be minus 5. Be careful there. That's a very common mistake. So that's what happens below the line here. We multiply these two together and we're left with 1 minus 5. Above the line, of course, it will be 8 times all of that. Okay. I'm not going to expand that bracket because look what happens next. We got 8, 1 plus root 5 above the line, and 1 minus 5 is negative 4. Now 8 divided by 4 is, of course, 2, and a plus and a minus is a minus. And there you have the right. Okay. It is now rationalized in the denominator, and we have simplified. So I believe that is the correct answer. Of course, you can, if you want, expand the brackets, which gives you minus 2 root 5, which is the same thing. Let's look at the mark scheme. Yep, there is without the brackets expanded or with the bracket expanded. That doesn't matter. Okay, you get 1 mark for multiplying it by 1 plus root 5. So it looks like this. Just by writing this part down, get 1 mark for this. 1 mark for the final correct answer, or this is also correct. Yeah, just a little bit of practice and you'll nail it in no time. Next one, again, this is just practice. There are different ways to do this, but the straightforward way is just to do 2 brackets, simplify, and then do that bracket with the last one. Okay, which means we'll do 2x times x, which is 2x squared. 2x times 1 is 2x, minus 3 times x is minus 3x, and minus 3 times 1, a minus and a plus is a minus. This is where everybody gets wrong. And then 3 times 1 is 3. And the 2 minus 3x is hanging around waiting for its turn. Let's just simplify this first. We got the 2x squared. Minus 2x minus 3x will give us minus 1x, of course. Okay. Bam. So we've done the first bracket, and that is your first mark. Okay, actually the first part here, we can get the mark. I was simplifying it. Okay, just expanding one pair of brackets. Let's do a different color now. Now we're going to do this whole bracket, 3 terms with those 2 terms. We start with the first term, and we multiply it with the 2x, which will give us 4x squared. And then 2 times minus 3 is minus 6. And x squared times x is x cubed. Be careful there, yeah? With the sign and the x's, get that right. Do it slowly, think it through. Now we're doing the minus x. Let's do it above here. So minus x times 2 is minus 2x. And a minus, again, a minus and a minus gives us a plus. There's the 3 and then x times x, x squared. Go slowly, make sure you get it right. Last is the minus 3 times 2 is minus 6. And then a minus and a minus gives us a plus. 3 times 3 is 9. And there's only this x here. Oh, bam, we got it. Right, you get that right. If you make one mistake, you can still get this 1 mark. Same here. If you wrote a plus there, you can still get 1 mark there. Okay. So, then we just need to simplify it. Let's see. Let's start with the highest power. It's a minus 6x cubed. There's no other x cubed, so this one stays the same. Then the x squares, there's a 4x squared plus a 3x squared. The sign in front goes with the term, yeah? So 4 plus 7 is 7x squared. Next, we got the minus 2x plus 9x. You can say it's 9x minus 2x, so that will be plus 7x. And then there's just the minus 6, no other numbers. That's the final answer. Minus 6x cubed plus 7x squared plus 7x minus 6. Okay, there we go in the mark scheme. Okay, so here, yes, like I said, 1 mark if you expand the first pair of brackets and you can make 1 mistake. So that's the first mark over there. Okay. Then the second one is if you simplify, then the next one again here, like I said, and the final mark for the fully correct answer. Not too hard if you just practice this, yeah? And go slowly. Remember, a minus and a minus is a plus, a minus and a plus is a minus, and get those x's right. Question 21. This one is going to be fun. The diagram shows 2 right-angled triangles ABC and ACD. So when you see a right-angled triangle, you just know immediately 1 or 2 things is going to happen. If we work with all the sides only, we are going to use Pythagoras. Right? And then if we are going to work with the sides and angles, we are going to use SOHCAHTOA. So it shows a right angle triangle. They call it triangle ABC and ACD. Find the value of cos ADC. So we're looking at ADC, which is this side here. Yeah, ADC, right. So they mentioned cos. Where is the cos? There it is. There it is in the car ratio. So we need the adjacent and the hypotenuse. So we were talking about this angle here. The adjacent, of course, is the angle next to it, the one that is not the hypotenuse. So we need AD over A. Well, the problem is we have the adjacent, which is CD, which is 9. We don't have the hypotenuse. Alright, so that's a problem. Okay, what else is there? What about this side here? If we can find this side, we can use Pythagoras. So we're going to go first to the triangle down here. That's not what I want you to do. That's what I want you to do. Okay, the triangle down here, which we have an angle and a side. Okay, got this angle here, 30 degrees. Okay, we can use SOHCAHTOA. And let's label this triangle. I'm going to do this one with a different color. Okay, so opposite the B, the right angle, we got this. This is the hypotenuse for this triangle. You know what? Let's do start everything in greens. Okay, so this is the hypotenuse. Then this will be the opposite, and this will be the adjacent. So what we want, I want the hypotenuse, because then I got another side in this triangle. We have the opposite. So the S and the O, we're going to use the SOH ratio, which means we need to do sin 30 equals the opposite, which is 6 over the hypotenuse here, which is line AC. Nice. Okay. So I want to know what. Let's rearrange this. Multiply the AC over there and divide the sin over here. Actually, we're just swapping them around. So we say AC times this, and we divide. We don't change the sin minus 1 because it's moving with this angle. Right. Now we need to remember what is sin 30. This is one of the angles that you need to remember to do without a calculator. So let's draw a little table, right? If we got sin and cos. Okay, there's a few angles you need to know. 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Those we need to know what is their values without a calculator. Okay, so what do? This is what we do. We start here by sin. We write in 0, a 1, a 2, a 3, and a 4. Then we square root them all. Square root, square root, square root, square root, square root. And lastly, we divide each one by 2. And that is the answer. We just need to simplify it, right? So square root of 0 is 0. And 0 divided by 2 is 0. So sin 0 degrees is 0, which if you remember right, that is sin graph starts at 0. Square root of 1, of course, is 1. So the sin of 30 is a half. Square root 2 over 2, that is it. Okay, if you want to change it to the one that they use more often, we can multiply it by square root 2 over 2, which is 1. We can multiply anything by 1, which means square root 2 times square root 2 is 2. 2 times square root 2 is 2 square root 2. 2 divided by 2 is 1, so that's the same as 1 over square root 2. So if you want to write the version they usually give you, is 1 over square root 2. Okay, that one stays the same, square root 3 over 2. And the last one, square root 4 is 2, and 2 divided by 2 is 1. Done. I now have got all the values for sin 0, 30, 45, 60, and 90 without using a calculator. Cos, what do you do for cos? You just do it backwards, which means cos 90 is 0, cos 60 is a half, cos 45 is the same, cos 30 is square root 2, and cos 0 is 1 because that's 1. Either way, the one we're looking at is this one here, sin 30. Yeah, so that means we got 6 divided by a half. How many halves goes into 6? Yeah, there's 2 halves in 1, 4 halves in 2, so that means AC is 12, because there's 12 halves in 6. How many halves fits in 6? It makes sense. 2 halves fits in 1. Okay, anyway. Right, great stuff. So now we have AC, which is 12. Okay, but if you remember, we want cos ADC, so we want the A and the C. Right, so let's go to a different color here. So we want the hypotenuse, but now we got 2 sides of a triangle. We want to know the third one, so that simply is Pythagoras. Remember, Pythagoras is the hypotenuse, which in this case is AD. So that would be AD squared equal the other 2 sides, AC and CD squared. So it's AC plus CD squared. Okay, that means AD. So move that square to the other side. We root it. We just worked out AC is 12. And we worked out, given us CD is 9. Don't forget to square these. So AD, 12 times 12 goes 144. 9 times 9, 81. And then we add them together. Okay, 1 plus 4 is 5. 4 plus 8 is 12. Carry the 1, 225. Does that not look familiar? Okay, maybe you might remember this is a Pythagoras triple. Yeah, of course it's 15. What is 15 times 15? It's 525. What's it? How do you do this again? 5 times. No, we just put the 25 there. 5 times 10 is 50. 10 times 5 is 50. And then 10 times 10 is 100. Add it up, 5. That gives you 2. Carry that 2. So yeah, so you need to remember at least your square numbers up to 15 squared. Brilliant. Now we have this as 15. Okay, I think we are hot on the trail. So remember now, they want to know cos ADC. Cos ADC. Cos is the adjacent over the hypotenuse. That's 9 over 15. And that's our answer. 9/15. Cos ADC is 9/15. Of course, if you want to simplify it, divide both by 3. Then cos ADC is 3/5. But let's see what the mark scheme says. 9/15 is good enough or equivalent. So if you do simplify it, that is fine as well. Okay. So let's just see where the marks lie here. Right. You get 1 mark for writing this down and 1 mark for getting the answer there. Okay. And then you get 1 mark for this square, these two square roots, and then another one for square rooting it. For squaring it, adding together, you get 1 mark, and for square rooting it, another one. And then, of course, the final mark is 9/15. Alright, you can do this. Break it down into little parts, practice it at home, questions like this, and you're sorted. Question 22. All length is given in centimeters. Triangle ABC is mathematically similar to triangle ADE. Let's just draw that a different way. Okay, so we see what that means. So triangle ABC is the big triangle. Can we just big triangle, that one there. The C is here, the B is there, the A is there. That BC is 10. And AC is x plus 5 plus 7 plus 5. So we add that together, the 5 plus 7 plus 5, that will be 12.5, right? That's from A to C. Then there's a smaller triangle, which was put on top of it, yeah? Where we got D here, E here, and A there. DE is 2x, and AE is x plus 5. So that's, I just separated the 2 triangles, so things are a little bit clearer. Okay, now remember, with similar triangles, the ratios of the sides is the same. Okay, that means if we do BC divided by DE, if we do 10 divided by 2x, let's say it was 10 and 2, right? That means that the smaller triangle is 5 times smaller, and the bigger is 5 times bigger. If the x wasn't there, there's an x, which complicates things. But if it was 10 divided by 2, it means the scale factor is 5. The one is 5 times bigger. That means the other side would also be 5 times bigger. Okay, that's why we can write the other one. Remember, I do the big one over the small one. So we do AC, this one, over 12.5 divided by this. If the answer on the left was 5, this answer should also be 5. Okay, but it isn't, because there's an x, which is in there, misses it. Well, you get the idea. We can do it the other way around as well. And instead of saying the one triangle is 5 times bigger than the other one, it would just means we say the smaller one is a fifth of the bigger one if we swap it around. We can do that, of course. So now we just need to solve this equation. Okay, so x plus 5 is being divided here. We multiply it on the other side. So this will become 10 times the x plus 5. See, that just moves above the line. And same with the 2x. It goes over there. We multiply it. What's there? This is really nice now because we don't have any fractions left. It's now more linear. Now we just expand the brackets. 10 times x is 10x. 10 times 5, of course, is 50. 2x times x is 2x squared, and 2x times 12.5. 2 times 12.5, of course, is 25. And don't forget the x. Okay, you see, things are starting to look up. I'm going to leave the 2x squared plus 25 where it is. And then I'm going to move the 10x to this side. It becomes minus 10x. And the 50 to this side, it becomes minus 50. Or we subtract it from both sides. And on the left-hand side of my equation here, there's only left a 0. Okay, it's very important to keep the whole equation balanced. The equation, so you know what's going on. Okay, if you move things around too much, you get confused. Okay, so That means 2x squared. 25 minus 10 is 15x. Isn't this looking good? And then there's a minus 50 at the end. And we can just throw the equal 0 over there. Not that it really matters, but now we've shown exactly that is that. But to show that questions, showing every step is the most important part. Okay, so you can check here where the marks are. Okay, yeah, see, they've written the equation the other way around. They put the 2x at the top. You can do that, and the x plus 5 at the top. Anyway, this is 1 mark for writing this equation, right? Then for, okay, they didn't even add the 5 and the 7, 5 together, but of course we did that. So, or equivalent, anything equivalent to that. So theirs is just the other way around, but they're just multiplying on both sides, not even expanding the brackets. That's the second mark. And then all of that leading to this. Okay, so I mean, you get this mark if you have all the steps in between. Okay, that was a lot of fun. Then they say solve by factorizing. Now, there are different ways to do this. I'm going to show you one way. There's other ways on the internet as well, right? So we need to factorize this quadratic equation with a coefficient there that is not 1. Okay, remember, this is the A, this is the B, this is the C. So first thing I'm going to do, I'm going to multiply the A and the C together, which is the 2 and the minus 50. That gives us minus 100. Now we need to think about two numbers. If we multiply them together, we get minus 100. And if we add them, we get 15. Okay, think about that, right? So for example, if we do 2 times 50, when we add them together, we'll get minus 48. That's not what we want. We want 15. So that was not going to work. What other two numbers do we multiply together? If you think like 25 times 4, yeah, that's 100. But 25 and 4, there's no way that's going to be like a 15. What about 20 and 5? Okay, that looks up. Somehow that can be 15. Now remember, we got a minus 100. So one of these needs to be negative. So if we make this one negative, 20 minus 5 is 15. Now that is what we want. Okay. We multiply them together, we get what we got here. We add them together, we get that. Okay. So that means our two terms, okay. So what we got? We got 20 times minus 5 is minus 100, same as that. And when we add them together, we get a positive 15, same as that. So our two terms is positive 20 and negative 5. So now we're just going to put it into brackets, because that's what factorizing is. I'm first going to put 2x squared in both brackets. No, 2x squared, just 2x. Okay, so it's not going to work yet because we multiply this, we get 4x squared and 2x squared. Okay, 20, a positive 20 is goes in one bracket and the minus 5 in the other one. Now, just see if we can simplify one of those brackets. And yes, this one I can divide both terms by 2, which will give us x plus 10, and the other one there's no common factor, and that's the answer, right? We can check if that's correct if we expand the brackets. X times 2x is 2x squared. Bam, that's good. X times minus 5 is minus 5x. 10 times 2 is 20x. Together this will give us 15x. Excellent. And then 10 times minus 5 is minus 50. That's what we wanted. So we have factorized these brackets correctly. Okay. Next step, of course, is now to solve. Okay. You see there? They made the y 0. So they've made this equal to 0. So now we can just split it up. We can say x plus 10 equals 0. Move the 10 to the other side, it gives us x equals minus 10. We got one solution. And then 2x minus 5 equals 0, which means 2x equals 5, and then x will equal 5 over 2, or 2.5, whichever way you want to write it. 2.5 is what I'm going to write. Mark scheme, yeah, they put 2 and 5, or equivalent, so you can write 2 and 1 over 2 or 5 over 2, anything doesn't matter. Okay, so you get 1 mark. Okay, look, if A times B is minus 50. So let's say you've got this the wrong way around. You've got the 10 there and the minus 5 there. But you multiply them together, you get minus 50. That's a mark already. But for fully correct factorization, 2 marks. And then that's it. 2 marks already for that. Yeah, fully correct factorize, 2 marks. If it's not right, but yeah, there's all these funny rules there. Okay, you get 1 mark and then 1 mark for both of these correct. Nice. Okay, isn't that fun? Right, next one. Find the length of AC. This is this one here. Okay, so we know the length of AC is x plus 5 plus 7.5, which will give us x plus 12.5. Okay. Now we got 2 x's. Okay, so we can have minus 10, you see here, plus 12.5, which will give us 2.5. Or x can be 2.5 plus 12.5 is 15. Which one do you think is it? 2.5 or 15? Looking at these triangles, it must be 15. Okay. What do you think? Yeah, that's the 15. Okay, if whatever your positive root is here, if you got something else, but you add it to 12.5, you get here a follow-through mark. Okay, so you can have a different answer and have it correct. Question B. The area of triangle ABC is k centimeters squared. Find an expression for the area of the quadrilateral BCED. Give your answer in terms of k. Look here, mate. We got this shape. And we got that one there. Triangle. This one is ABC. Where's the B? Where's the C? ABC. They tell us the area is k centimeters squared. Then we got ADE. How much bigger than the other one is it? Okay. Well, we got now AC is 15. Okay. And AE, well, remember X is 2.5. So that is 7.5 as well. So that's 7.5, isn't it? Do you understand what's going on here? Yes. AC is 15. Yeah, that makes sense. AC is 15. So that's 7.5. That's 7.5. E is in the middle. Okay. So what does that mean? Okay. That means if we're going from here to there, we need to multiply it by a half. This one is half that one. 7, yeah? Does it make sense? Because 7.5 divided by 15 is a half. Makes sense, isn't it? Okay. Now, the thing is, when we go from there to there with the area, do we multiply it by a half? No, we don't, because area is not the same as a linear scale factor. In fact, we need to multiply it by a half squared. What's a half squared? A half times a half is a quarter. And the same with volume. If you're going to multiply the volume scale factor, you're going to multiply it by a half cubed. Does that make sense? Let me show you another example, right? got a line here that is 1 centimeter long. I got here, then it's 2 centimeters. That is twice as big, right? So the scale factor, linear scale factor there is 2. That line is twice the length of that line. But if I make this into a square, right, the area of the square will be 1 centimeter square, but the area of this centimeter will be 4 centimeters square. So now the area scale factor, you need to do 1 times 4. Bam. See? It is 2 squared. So that's why if this is k centimeter square, this will be a quarter centimeter square. Okay, or k over 4 centimeter square. That is the area of the smaller triangle. Okay, now they've taken this triangle, this one, and they put it over that one there, like this. And that is D, and that is E, and they want us to tell what is the area of the quadrilateral BCED, this part here, okay? So it's the whole 1k minus the area of this one. So what's that going to be? That's going to be k minus a quarter k, or k over 4. Right. What is 1 minus a quarter? What is 1 minus a quarter? Okay. 1, of course, is 4 quarters, right? If you got one pizza, you got a pizza sliced in 4 slices. It's the same, you still have one pizza. So that is 3 quarters, of course. So the answer here is 3 quarters. Okay. Okay. Or you can write 3k over 4. This is the same thing. Let's see what the mark scheme say. 3 quarters k, or 3k over 4, or equivalent, or 0.75k. Now there is a massive explanation there that does your head in. I think it's easier here if we just look here, right? Basically, you get a mark for a quarter k, or k over 4, and then a mark for the answer. A lot to do to think for 2 marks. Okay, you can do it. Question 23. Venn diagrams. Just remember this. Union. Everything. Intersection. Has to be both. For example, union, everything. If there's A and B, everything there, everything there. Okay. Intersection. Has to be both. Has to be an A and a B. You get the idea. Okay. This is or. In the one, or in the other one, or in both. This is and. In the one and in the other one. Okay. So, here we go. We're ready. Take your pencil. You say P. What is P? Okay. This is in P. This is in P. This is in P. This is in P. That all those parts is in P. Nice. Okay, remember P was green. Q. This is all Q. Yeah. This. But we got the comma there, which means the, what was the word again? Opposite. Everything that is not in Q. What is not in Q? This is not in Q. This is not in Q. This is not in Q. And the outside here, this is not in Q. Okay, the complement of Q. Right, done that one, right? Then, what should we do? Purple. Okay, then we got the R. This is an R, this is R, this is R, this is R. This is all R. But again, we got the complement. We got the little comma there. So it means everything that's not an R. This is not an R. This is not an R. This is not an R. Oh, this is an R. This is not an R. Okay. We have now marked those three sections. Now remember this. If it was intersection, if those were all intersections, it had to be P in P, and it had to be not in Q, and it had to be not in R, and that would be only this region here. That's intersections, okay? But it's not. It's union. Union is or. Or this, or that, or that. And that just means every single thing that has a dot, doesn't matter the dot, all the dots we are going to shade. Okay? We are going to shade this area here. Why? Because it's not in R. So you have to shade it. Okay. We're going to shade this area here. Why? Because it is in P and it's not in R. We're going to shade this one here because it's in P. Because it's union. If it's in P, we shade it. We shade here because it's in P and it's not in Q. We shade this one here because it's in P, it's not in Q, not in R. Okay. We shade here. Why? Because it is not in Q. Yeah? Because it's union. And we shade the outside because it's not in P and it's not in R. Okay. That's how union works. If it is any one of the requirements it fulfills, you shade it. Okay. If you can break this down into little parts, step by step, it's not that difficult to do. Look at the mark scheme. There's only one mark here to award, so you either got it or not, okay? Oh my goodness, what happened there? Sweet. Rearrange, make P the subject, and everybody's like, but there are two P's. Yes, there's two P's. There's two P's. We need to make them one P. That's true. Okay, first of all, you cannot subtract or move the 3 because it's being divided by all of that. You need to sort that out first, before you move a 3. Same with the 2 or anything. You can't because it's being divided by all of that. You need to get rid of that. So what we can do is everything at the top is being divided by everything at the bottom. So we can multiply everything at the bottom on the left or on both sides. So that will be D times 2 minus PY equals 2P plus 3. First step, I got rid of all the fractions. And that's your first mark as well, of course, probably, I think. I don't know, I'll check later. Okay, what is there to do now? What can we do? Well, with one thing we can do, we can expand those brackets. D times 2 is 2D, and D times minus PY is DPY in any order. Okay, nice. Right, now we still have those two P's. There's a P here, and there's a P there. Okay, remember, making the subject, we get the P alone. It doesn't matter on what side of the equal it is, okay? So the only logical thing to do then is to move all the terms with a P to the same side. Now I'm gonna move this term here. Okay, let me just show you exactly what. This term here, I'm gonna move it to the other side. So only because this one is negative and then it will become positive. Because I can move this 2P to this side, but then I'll have two negative terms. Well, there's nothing wrong with it. Just negatives. I want to be more positive. All right, so that becomes plus dpy. And of course, any terms on the right-hand side which is not have a p, I don't want them there because they should go to the other side. Meaning is this plus 3, I'm going to take to that side. Okay, remember there is the 2d is there. Don't lose it. The plus 3 goes here, it becomes minus 3. Okay, now at least we got all the p's on the same side. You see it's there, and there's one there. Okay, that's weird. What we can do now is factorize. Take this p, make a bracket, put it in front. Inside the bracket, we put the terms that is left. There's a 2, there's a plus, and a dy. Okay, so we haven't changed the equation. P times 2 is 2p, p times dy is dpy. If I expand the brackets, I still have the previous term, so everything is still correct. And on the left, I got 2d minus 3. Okay, now there's only one thing left to do. 2 plus dy, that's being multiplied by p. So if I want to move that to the other side, I'm going to have to divide it. And that's the answer. Look, the p is alone. I can just write that over here then. 2d minus 3 over 2 plus dy. Check the mark scheme. Okay. Or equivalent, I mean, you can swap it, right? You can have dy plus 2, for example. Or you get minus 3 plus 2d. Who knows why you would have that, but yeah, you could. Okay, let's check the marks. Yes, it's multiplying on the left. That is 1 mark. Okay, putting all the terms with the p's and one side, like I did here, that's another mark. This is not red. Okay, that's another mark. Factorizing. So here, that's the third mark, and then of course your final answer. Okay. Again, a little bit of practice and you've got this sorted. By this time in the exam, you're like, fine, I made it to the last page, but also, this is usually the hardest questions. Or is it? Anything to the power of 0. Anything to the power of 0 is always 1. Easy as that, yeah? 1. Remember that fact. Bam, then they hit us with this thing. Okay, now remember, everything inside the bracket is to the power of 2/3. Okay, that means 81 is to the power of 2/3. M to the power of 8 is to the power of 2/3. Now, power to a power, remember your index rules. If you got a power to a power, what do? You multiply them together. So 8 times 2/3. Okay, the 3 there, that's to the power of 2/3, and then the last one, the 2 times to the power of 2/3. My goodness. Well, that's a start. Next index rule you need to remember is the fraction rule. Okay, anything to the power of a fraction can be written as a root. You see where that x went? Is the root of that. Okay, meaning, remember that 9 to the power of a half is the same as square root 9. You get it? Okay, yes. So, for 81 to the power of 2/3 would be the same as root 81 squared. Yeah, that's it. And 3 to the power of 2/3 will be cube root 3 squared. So let's do that. We've got cube root 81 squared over cube root 3 squared. We're making progress slowly. This is the one where they're really trying to break your bones now, yeah. They're trying to break your soul. You just need to say, I'm better than this. I'm tougher than this. I can do this. Or maybe I'm just making it harder than it is. Who knows? Okay, here. 8 times 2/3. What's 8 times 2/3? 8 times 2 is 16. So that will be m 16 over 3. And then we do 2 times 2/3. 2 times 2 is 4 over 1/3. Right, this is where I feel like I could be getting a little stuck. Now, this one on the left looks hard, but I know here that if you divide, remember the next rule of indices. If you're dividing with the same base numbers, you need to subtract. So these are the same base number and we're dividing, so we need to do 16 over 3 minus 4 over 3. 16 minus 4, but no, denominator is the same. Goodness grief, they're making something easier. 16 minus 4 is 12 over 3, and that is 4, so brilliant. Okay, so that means m 16 over 3 divided by m 4 over 3 will give us m to the power of 4. And I'm going to write that there, and I'm sure that's going to give me some marks. Now we can sort out this problem here. Let's see, we got the cube root of 81. What do I know about cube numbers? Like 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed, 4 times 4 is 64. Okay. 5 cubed is 125. Is there any of these numbers that got anything to do with 81? Okay, I'm looking at that one there, right? The 3 cubed. Because what is 27 times 3? That is 81. That means we can write 81 as 27 times 3. So if we got the cube root of 81, that could be the cube root of 27 times 3. Now we know the cube root of 27 is 3, but we can't work out the cube root of 3. Yep. Okay, so remember we're looking at this part over here. So we can write that now as cube root 81 as, remember that 3 is there, right? So it's 3 root 3, 3. So 3 times squared over root 3, 3 squared. Okay, I've already sorted this bit out. Now, yeah, it's over there. So I'm just working with this. Right, now, everything here is squared. So we square the 3, it becomes 9. But we still have the root 3. That's still being squared. Remember, that's cube root. Don't forget that 3. My goodness. And here we got, there we go. You see, that's the same. So now they can cancel each other. We're left with 9. Massive question here. Yeah, I think you're gonna have to go back through this slowly and check every step I've done there. It was a bit messy at times. Okay, let's see where the marks is. It's basically 1 mark for 9, 1 mark for 4. Or you got 27. There's a 27. That's a mark. I'm going to have to go through this one again. Okay, last question. This is the final one. They want to really get to you. Okay. Now, see that 2? We can get all of these at 2. Okay, this is powers of 2. Let's look at the powers of 2. Just 2 to the power of 0, which is 1. There's 2 to the power of 1, which is 2. There's 2 squared, which is 4. There's 2 cubed, which is 8. There's 2 to the power of 4, which is 16. There's 2 to the power of 5, which is 32. Nice, right? So we can write this 32 as 2 to the power of 5, but that x is still going to hang around at the top. That was good, that was good. What if we continue it the other way, right? 2 to the power of minus 1, of course that's a half. Remember, the 2 just goes below the line. 2 to the power of minus 2, that will be 1 over 2 squared, which is a quarter. Nice. So we can write that 1/4 as 2 to the power of minus 2. Now all the base numbers are the same. Okay. Remember the rule of indices. If the base numbers are the same, we need to add the indices. So that means here, this will become 5x plus x plus 3 equals 2 to the power minus 1. Okay. Now, because the base numbers are the same, it means 5x plus x plus 3 equals minus 2. 5x plus x plus 3 equals minus 2. We can, of course, add the x's together. 5x plus 1x is 6x. Next, we can subtract the 3. So that will give us minus 5. And then we divide the 6. 1 over 5 over 6. And then you're like, yes, I've done the last question. I've got it right. I'm a genius. Okay. I see they've got an and there. Yeah. So you need to have this and this for 1 mark. Okay. And then for this step, 1 mark. And the final answer. Bam. Yes. This paper has been a challenge, but it's good. Practice these hard papers and you will definitely do well in your final exam. Stick with it. See you again soon. Bye bye.